Hi everyone, in this video we are going to talk about how to solve problems in the dynamics of a particle moving in a straight line. In this video, we will continue solving the problem for question number 4. First, let's identify the given information from the question and draw a force diagram acting on both the train and the carriage. I have drawn two boxes. One represents the train engine with a mass of 6,400 kilograms and the other represents the carriage with a mass of 1,600 kilograms. I also added a tension force because they are linked. The train has a driving force F of 12,000 Newton. There are resistance force acting on both the train and the carriage, R and 2,000 Newton. Since the question mentioned the train first and the carriage as well as R first and 2,000 Newton second, this means that R is the resistance acting on the train while 2,000 Newton is the resistance acting on the carriage. From the question, we know that the driving force causes both the train and the carriage to move with an acceleration of 0.5 meter per second squared. Now, let's find the value of R. Let's use the formula sum of force equals total mass times acceleration. From the question, we know that there are frictional forces acting on both the train and the carriage. This means that the driving force of 12,000 Newton will be reduced by the total frictional force acting on both. So the sum of forces becomes 12,000 minus in bracket 1,600 plus R. The total mass we should use is the mass of the train plus the mass of the carriage because the driving force make the carriage and the train accelerate in the same direction with the same acceleration, which is 0.5 meter per second squared. Let's solve them mathematically, then we can find the value of R, which is 6,000 Newton. Let's continue to question 4 part B. Find the tension in the sun. From the first force diagram, we see that the tension only affects the carriage. Without the tension, the carriage cannot move, but without tension, the train still can move. This confirms that the tension force acts on the carriage. However, in this case, the tension force is not fully effective because there is a frictional force acting between the carriage and the railway. According to the formula, the sum of forces equals mass times acceleration. For the carriage to move forward, the tension force must be greater than the frictional force. So we set up the equation tension minus friction equals the mass of the carriage times acceleration. After solving, we find that the tension force is 2,800 Newton. Question 5. Let's read the question first and then let's draw the force diagram for the particles. This will make it easier for us to identify the movement of both particles. There are two particles P and Q that are connected by a string, P 0.5 kg and Q 0.4 kg. Since both particles P and Q have mass, they each experience a weight force due to gravity. The particles also experience tension because they are connected by a string. The string is assumed to be light and inextensible. Therefore, we can say that the tension in both positions is the same and the acceleration of both positions is also the same. But since P is heavier than Q, we can say that P must move downward while Q must move upward. However, the acceleration values are the same even though they have different direction. Because of this, we cannot solve them together in a single equation. Now let's divide them into two parts, one for P and one for Q. For particle P, we only consider the forces acting on P and its acceleration. The sum of forces acting on P equals the mass of P times its acceleration. Since P moves downwards, it means that the weight of P is greater than the tension T. Therefore, we set up the equation weight of P minus tension equals mass of P times acceleration. By substituting the values, you will get two equations for P. You can use either one depending on which you understand better. Do the same steps to find the equation for part Q. Since particle Q is moving upward, it means the tension is greater than the weight of Q. So, the sum of forces acting on particle Q equals the mass of Q times acceleration. Tension minus the weight of Q equals the mass of Q times acceleration. By substituting the value, you will get two equations for Q. You can use either one depending on which you understand better. Question 5b. Find the tension in the string immediately after the particles are released. We have four equations, but this time I want to use the equation T equals in part P and part Q. Since the tension in part Q and part P is the same, we can combine them into one equation. T in part Q equals T in part P. 0.4a plus 4 equals 5 minus 0.5a. Solve it mathematically, then we get A, which is 1.1 meter per second squared. After that, we can choose from the four equations to find T. But this time, I want to use T equals 0.4a plus 4. And then we get T, which is 4.44 Newton. Question 5c. Find the acceleration of P after the particles are released. We already found A in part B, so the answer is 1.1 meter per second squared. Question number 5. A box P of mass 2.5 kg rests on a rough horizontal table. Rough horizontals means there are frictional force acting between P and the table. Now let's draw all the forces acting on P and Q. There is a tension between P and Q because they are connected by a string. Next, since Q is hanging and has mass, a gravitational force acts on it. We can calculate the weight of Q as 1.5 kg multiplied by gravity, which is 9.8 meter per second squared. Then we get 14.7 Newton. After being released, Q moved a distance of 0.8 meter in 0.75 seconds. Let's write that S equals 0.8 meters and T equals 0.75 seconds. Since the particle is released from rest, it means U equals 0. Now let's find the acceleration of Q, but first draw the direction of acceleration. Since Q is heading, it will move downward. Then, if particle P move, it will move to the right. In this case, we cannot use the formula sum of force equals mass times acceleration because there are two missing quantities, tension and acceleration. However, don't worry, we still have four kinematics formula. Choose the one that includes S, T, U, and A since you need to find A and you already have S, T, and U. Let's choose the first formula, S equals UT plus half AT squared, and then substitute all numbers, and we got A equals 2.84 meter per second squared. Next question, show that the tension in the string is 10.4 Newton. Alright, now let's divide them into two parts. Because they have different direction of motion, particle Q move downward and particle P move to the right, so we cannot calculate them in one equation. Let's choose particle Q because in particle Q we already know the weight of Q and we only need to find the tension. Why don't we use particle P? Because in particle P we still don't know the tension and friction, so it is difficult for us to determine the values of tension and friction. Since particle Q moves downward, the weight of Q is greater than the tension. So we can write the sum of forces acting on particle Q equals mass of Q times acceleration. Weight of Q minus tension equals mass of Q times acceleration. Substitute all numbers, then we can find T, which is 10.43 Newton. Next question. Find the value of K. From the question, we know that the frictional force acting between P and the table, it is given as K, so we replace frictional force with the letter K. Now let's look at part P. The sum of forces acting on P includes tension and friction. Since P moves to the right, it means tension is greater than friction. So tension minus k equals mass times acceleration. Substitute all numbers and then we get k as 3.33 Newton. Okay guys, this is the end of this video. Thank you for watching. I hope this explanation helped you understand this concept better. Keep learning and stay curious. See you in the next video. Bye.